You're sitting in a dusty university lab in 1997. Kishan Mehrotra and Chilukuri Mohan just laid out the neural network models like a deck of cards, each algorithm a different player in a game of prediction. But here's the kicker. It's not just theory. These networks don't just study data. They adapt, they learn, they surprise. How do these digital brains really work, and can they actually change the way we solve real-world problems? That mystery is where we dive in. Let's start with the core engine driving neural nets, how simple perceptrons evolved into powerful backpropagation algorithms. It's a journey from guesswork to precision, a real leap in machine learning's infancy. In 1958, Frank Rosenblatt invented the perceptron, a simple algorithm that recognized patterns like handwritten letters. Mehrotra and Mohan show how this humble model, built to mimic a single brain neuron, was the first step towards machines that could learn. Imagine it as the spark that turned static machines into potential learners. Backpropagation is like a coach who watches every play and tells you exactly where you messed up. Think of it as a finely tuned GPS recalculating the best route after every wrong turn. The book explains with clear pseudocode how errors in output are sent backward through the network, adjusting thousands of tiny weights, layer by layer, transforming guesses into increasingly accurate answers. With these tools, students launching projects from weather prediction to stock analysis could hit the ground running. The book stresses how including the latest 95 algorithms meant learners weren't stuck in the past. Imagine starting a race with the best shoes already laced. This practical approach helps you build models that actually work outside the classroom. Supervised learning teaches networks with labeled data. But what if you don't have neat answers? Mehrotra and Mohan dive into unsupervised and associative models, where neural nets find hidden patterns and associate clues like an instinctive detective. Imagine you're handed a million unlabeled customer profiles. What do you do? The book explores clustering models like Kohonen's maps that automatically group similar data. It's like sorting thousands of mixed puzzle pieces without the picture on the box, letting the network organize complexity all by itself. Associative models work like your brain when you recognize a face with just a glance or complete a song from a few notes. Mehrotra and Mohan describe how these nets can recall full patterns from partial data, storing info in dynamic memories, much like a supercharged mental filing cabinet ready to pull info on demand. By connecting neural networks to economics and management, the authors reveal new ways to predict market trends or optimize operations without rigid formulas. This makes the models less like cold math and more like savvy business partners, spotting opportunities in chaotic, unlabeled data streams. Neural networks aren't magic, they're math, and optimizing them is an art form. Mehrotra and Mohan don't just drop fancy equations. They show you how optimization methods sharpen neural nets into powerful tools. The book dives into gradient descent, where the network tweaks its parameters step by step, like a climber descending a rugged mountain to find the deepest valley, or the most accurate model fit. This optimization method keeps networks from wandering aimlessly and ensures steady, purposeful learning. What's really cool, Mehrotra and Mohan include algorithms fresh as 1995, like resilient backprop and conjugate gradient methods. These advances speed up training and reduce errors, turning old slow learners into athletes sprinting to solutions. It's like swapping a tricycle for a superbike in your AI toolkit. Best of all, the book offers real software implementations, not just theory. That means you can jump from pseudocode to real code, using tools that bridge computer science and stats seamlessly. It's the difference between reading a recipe and cooking a real feast, ready to serve in your next project. Back in that 1997 lab, those early neural nets were just starting to learn, and so can you. From simple perceptrons to advanced optimization, the tools Mehrotra and Mohan unpack aren't just theory, they're an invitation. So grab a dataset that puzzles you, apply a basic backprop algorithm, and see how your digital brain finds patterns where you didn't expect it. That's neural networks in action, learning by doing. Subscribe for more book summaries like this one.